The SDM4FZI research project is funded as part of the Future Investments in the Vehicle Industry Funding Program of the Federal Ministry of Economics and Climate Protection. The funding started in October 2021 and will last 3.5 years. VDA5050 is the definition of a universally applicable communication interface for exchanging order and status data between a central master control, fleet manager, and automated guided vehicles (AGVs). The VDA5050 simplifies the connection of new vehicles to an existing master control system and enables parallel operation with AGVs from different manufacturers, plug-and-play capability. The communication protocol is MQTT, using JSON structures for the messages. The basic layout structure is a graph of nodes, which are connected by edges. AGVs traverse nodes and edges and perform actions as communicated by the fleet manager to fulfill their orders. The accompanying layout interchange format, LIF, by the VDMA specifies how layout information is exchanged in JSON format. SimPlan has implemented a VDA5050 interface in plant simulation, utilizing the built-in MQTT and AGV features. It also includes import functionality for LIF files to automatically generate the layout graph in the simulation model, as defined by the fleet manager. This enables the virtual commissioning of any AGV fleet manager that adheres to the VDA5050 standard. As part of the research project SDM4FZI, the Python-based VDA5050 fleet manager by the IFL from KIT was connected successfully. Here we also defined a JSON scheme to send transport requests from the simulation model to the fleet manager, which is not in the scope of VDA5050. One main aspect of VDA5050 is the specification of orders and order updates for the AGVs. An order defines the nodes that are released for the AGV to traverse and possibly actions, such as pick and drop, to perform on the nodes. The currently released nodes are highlighted for each AGV in the animation. Furthermore, we developed the intralogistics map export format together, which provides physical layout information from the simulation model, that is location and dimension of obstacles, stations, and the interaction points for loading and unloading at stations. With this information, the IFL creates the optimal graph for its fleet manager.